Alright, here goes another video on trig identities, and this one's just going to be simplifying. It's going to be much shorter than the last video because the last video needed to cover what things meant and go into things a little bit more in detail. If you want, have that sheet with some of the rules right in front of you or tips, but this one is just going to be simplifying. So we're just going to do what the directions say, combine fractions and simplify. In the next video, we might be doing that to prove an identity. So remember, these videos are just little mini pieces to what would be a proving an identity type of question, okay? So just keep that in mind. So this first example, what are we doing? We are going to combine fractions. Well, how do you add or subtract fractions? You need a common denominator. So that's the first thing we're going to do. Our common denominator is going to be sine x times cosine x. So first step, common denominators. So sine x over here, cosine x over here. So this side needs the sine x. This side needs the cosine x. So first step, sine x, cosine x in your denominator. And this side, cosine x times secant x is 1. Why is it 1? Because they're reciprocals. 2 times 1/2 is 1. So cosine times 1 over cosine is also 1. Minus sine x times sine x is sine squared x. First step, done. Now what can we do? Well, we're just simplifying, so yes, we can simplify more. Notice it doesn't say to a single term. Notice it doesn't say we can't divide. We're just going to keep on simplifying until it's as simple as we can possibly get. So what do you recognize in the top? 1 minus sine squared x is a Pythagorean identity. Remember, sine squared plus cosine squared is equal to 1. So cosine squared is actually equal to 1 minus sine squared when you move it to the other side. So 1 minus sine squared x is cosine squared x. And of course over sine x, cosine x. The next step should be pretty obvious. You have 2 cosines on top and 1 on the bottom, so you can cancel 1 on top and 1 on bottom. So you're now left with cosine x over sine x. And yes, you can go one more step. Cosine over sine is cotangent x. Done! That's it. That's all we needed you to do for this example. This one was just to practice adding or subtracting fractions, which means you need common denominators, and also to remind you of Pythagorean identities. Now this next one, or these next two, we're going to factor. So yes, old school factoring. You need to be able to use old school factoring. And you also, right here, need to be able to do Pythagorean identity. So you have cosine squared x. Cosine squared x, if you remember what we had at top, would be the same as 1 minus sine squared x. So we have sine x minus, and this would be 1 minus sine squared x, and then of course minus 1 on the outside. Distribute your negative, and you have sine x minus 1 plus sine squared x minus another 1. And then that would simplify to sine squared x plus sine x minus 2. Okay? So we did say factor. So this is the exact same example as x squared plus x minus 2. So just to show you, what multiplies to a negative 2 but adds to 1 would be x plus 2 and x minus 1. So over here, we're going to do the same thing, but now we have signs on them. So what? This is just going to simplify to sine squared x plus 2 and sine x plus 2 and sine x minus 1. That's it. All we did was factor. So yes, you can factor these. Okay? And that's it. We're done. We were asked to factor using one trig function, so we factored in terms of sine. We're done. Nothing else. Now the next example is another factoring question. So instead of factoring it for you, I'm just going to let you try it. Factor this one. The only thing you have to do is rearrange that second fraction to just a sign. Rearrange it. Simple. Then factor it. So pause it, try it, come back when you're ready. So the first thing you should have done is rewrite this as sine squared x plus 2 sine x plus 1. Because remember, cosecant in the denominator is just sine on top. So we just need to ask ourselves what multiplies to 1 but adds to 2. Just like x squared plus 2x plus 1. This would simplify to x plus 1 and x plus 1. In this case, it would be sine x plus 1 times sine x plus 1. So yes, you have to be very good at factoring to do identities as well. And of course, this could be just written as sine x plus 1 quantity squared. And you're done. There's nothing else you can do. We're not going to FOIL it because that would just take us back to where we came from. So we're good to go. It said factor, leave it alone. Okay? Last example, same thing, simplify, one trig function, but yes, you're going to have to factor first. So again, pause the video, factor, cancel, and be done. Give it a try on your own. So tangent squared alpha minus 1 is the same thing as x squared minus 1. It's the difference of two squares. So if x squared minus 1 factors to x plus 1, x minus 1, then tangent squared alpha minus 1 is going to factor to tangent of alpha plus 1 times tangent of alpha minus 1. And of course, that's all over 1 plus tangent of alpha. Well, we know 1 plus tangent is the same as tangent plus 1, so these guys right here cancel each other out. So this gets simplified to tangent of alpha minus 1, and you're finished. We're in one trig function, nothing else we can do, so we're done. Leave it alone. And that's it for this video. So again, this video is basically another step towards doing proofs. So what we've done is add some fractions, we've done some Pythagorean identities, we've done some factoring. All of those tools are going to be used to do proofs. Now, what would proof be? So for the first example, we said simplify. Well, in the next one, when we start doing proofs, we will say simplify that till it gets all the way to cotangent x and then stop. So you're just simplifying to exactly what we're telling you to simplify it to. In number 2, we would tell you to simplify, or those are just terms of factoring. We would tell you to simplify to that, but that's easy. This last example, we would say simplify the problem until it gets to tangent of alpha minus 1. And that's it. So it kind of is a little bit easier because you know exactly where you're going, so you can use a thought process to help get you there. It's not like you're just wondering if you're done or not. Okay? So that's it for this video. Next one, we're going to start proving. This is Longo and I'm out. See you, bye.